start the recording and continue. Okay, this morning we talk about the inner class, then we talk about the different features of OOP, encapsulation, inheritance, abstraction, and polymorphism. So when we talk about a polymorphism, we are talking, and also when we talk about the inheritance, we're saying the static function cannot be overridden and the non-static function can be override. And during the polymorphism, you need to take a look what's the actual object type it is and what's the reference type it is. They're going to restrict the function you can call and the function behavior. So that's basically what we discussed this morning. And let's continue to take a look at the thing here. So in the morning, we concentrate on override. Now let's talk about what is overload. Okay, overload compared to override is a very easy feature. It's basically overload. Okay, so what's mean overload? So let's say I have a class called my house. I have win and I have tree. And then in the same class, I can define another function, public void tree. For example, same thing, exactly the same. Okay, but apparently Java does not allow us to do such thing. Please keep joining. Okay, Java does not allow us to do this. We cannot. Is there anyone who cannot see my screen? Who's keep doing join and quit? Is there anybody who cannot see my screen? If you can't, please stay in the room. Okay, do not keep quitting. All right, so can we actually have functions like this? We cannot. But if we do some modification on a function, then we can. For example, we can add int x in here. Okay. Now this behavior, like you're defining two functions with the same name, maybe same modifiers, same return, but different in the parameter, then Java allow you to do such. Okay. Now can we keep the same parameter but change the return type? No. Okay. Well, if you change the return type, then the function need to return an int. So let's return 1 in here. Java still not allow you to do this. Why is that? Because now you have two tree functions. Both of them does not require any parameter. And if you're calling the tree function like this, now which tree are you calling? Because the only difference is the return type. From the calling perspective, there's no way you can tell which function you're calling. So Java does not allow this from happening. Okay, Java doesn't care about your return type, you return int or you return void. As long as the function name are the same, then you must have different parameters in the same class. Okay, so this behavior, two functions, same name, maybe same return, same different return, but different parameter, we call this behavior overload. Okay, you can have two function overload, you can have one more function, two more, three more, whatever other functions, as long as their parameter are different and their function name are the same, then we call it overload. Okay, in a very old time, maybe 20 years ago or 10 years ago even, at that time when people talk about overload, they have a very naive concept saying the return type must be the same, which means you return void on top, you have to return void in the other one. And back then, when people are saying something like this, if you have different return type, then we don't call this, we're not calling this behavior overload. Okay. However, right now, these days, nobody care about too much of those. So as long as it looks like this, we call it overload. All right. So have we ever used overload before? Let me give you some example. Okay, so for example, you can use math. This is a class, and when I click dot, you can see there's a lot of functions. Now before we talk about these functions, question, are these functions static functions, or these are non-static functions? Anyone can take a guess?
Static.
Static.
Static, right? If they're non-static, then you cannot directly call it from the class. Since we can call it, they're static. Now, is there anybody use any non-static function from this class? For example, have you ever done anything like this? Ham equals new map, something like this? No. Okay, because
No.
class does not allow you to do so. How does it happen? We're going to talk. Let's take a look. Okay, the constructor is private. I haven't talked about the constructor, but if you guys know, then if the constructor is private, then we cannot call it, saying don't let anyone instantiate this class. Okay, so if nobody can instantiate this class, then all the functions inside this class, if you want to use, they must be static. Okay, if you look at through all these functions, they are all public static functions. Okay, now this kind of class in the industry, we call it util class or helper class, which means in the class there's no non-static function, they are all static functions. Okay, now for this kind of class, when we use it, we just directly call it. Now let's look at the max function on it, or absolute function. Okay, so max, you can send in to float or send in to int, to long, to double. Now, once you send in, no matter which one, 1 or 2, you're going to return you the big number, right? Now, all these max functions, currently, we can call it overload. Okay, they have different parameter, same function name. Now, let me give you another example. The most famous, widely used sysout, ABC. Look at this. The sysout on top is displaying a number. The sysout on the bottom is displaying ABC. Are they the same sysout function? Everybody uses sysout every day. But are we calling the same print line function here? Actually, no. Okay, how many sysout we have? If you type print line, you can see there's a lot of print lines. Receive an int, char, long, float, all these different types. Okay, or the last one without any parameter. So there are so many print lines. Every single print line, they take different parameters. So they are overloaded function. Okay, and they return void. So they are very typical overload functions. Okay, now this is overload. Overload also shows like a polymorphism feature. Basically, it's like when you do this, when you use it, for example, in here, when you use print line, you don't even care there have so many print line functions. You just send a string or send an int. You don't even need to know there do have a lot of print line function. When you use them, you just think you're calling the same function. And that's the whole purpose of why the overload exists. They don't want you to think of there have so many other different functions. They just want you to know there's only one function. As long as you call, you get whatever you want. Okay, so this is overload, and that's also called polymorphism. Means seems like only one function and showing you different behavior. It's able to receive an int or receive a string, but actually there's a lot. All right, these are some of the OP features we talked about, and the last one is a relationship. Okay, what is a? We talk about inheritance. We know we can have a parent class and a child class to extend the parent class. Now, can we say, for those who need this, I'm also gonna copy paste this in here. Okay, just in case you want to see it. All right, so if I have a class parent and a class sub to extend from parent, now, can I say parent, generally speaking, is a sub, or sub is a parent? Which one is correct? Or to be more specific, anyone want to try?
Sub is the parent.
Sub is a parent. So we can say this: parent P equals new sub, right? But we cannot do the reverse way. So you can say a new sub object is also a parent. Okay. So is a relationship. Sub is a parent. That's how we talk about. Or you can say array list is a list. Sub is a parent, but you cannot say list is an array list. Okay. So during the interview, they probably gonna directly ask you, explain to me what is a relationship and what is has a relationship. You need to know they're asking you these two features of OOP. All right, then let's talk about something back in this page 6. We have already cleared what is downcasting and what is upcasting. And we talk about what is concrete class, abstract class, and interface. Even we haven't finished the interface, but I'm gonna put it in here, okay? And the next thing I want to talk about the reference and value, okay? So what is reference value? This is a very classic question that even they used to have a debate, okay? I'm gonna give you two different questions. Let's say this, somewhere I have a function called foo. Forget about static or non-static, whatever, okay? So pseudocode in here. This foo function receives an x. And what it does is no matter what x you give me, I directly say x equal to 10. Okay? Now somewhere I'm defining an int x equal to 5. And I'm calling this foo function with the x as parameter. And after that, I'm going to system.out.println x. What will be displayed? This is question 1. Okay? Now question 2 is down here. Let's say I have a class called user. In this user, I have a non-static field called int age. And then I'm going to do this user u equals new user. And I will say u.age equals to 5. And then somewhere I have a function. For example, in this user, I have a function foo. Receive a user as parameter. And I will say no matter what you give me, u.age equal to 10. And I'm going to call u.foo u. And then I will call system.out.println u.h. Okay. Now question. What will be displayed? So these are two different questions, okay? Entirely two different questions. Question 1 and question 2. Anybody know what will be displayed for question 1 and 2?
For 1, it will display 10.
Agree?
I think the first one shall be 5.
5. What about the second one?
Second one shall be 10.
10. Okay.
Yeah, second one, 10.
Second one is 10. What about the first one?
It should be 5.
Okay, let's take a look at what actually happens. Okay, so somewhere, let's talk about the question 1 first. Somewhere I have a function called foo. Now, somewhere I'm defining an int x equal to 5. And then I'm calling the foo by passing in the x. Okay, now the question is, when I call this foo function take my input 5. Everybody know I'm sending this 5 inside. Once it goes inside, is the internal x still the same as my outside x? Or let me actually do this, okay? Foo function saying it takes a parameter x. Is that okay for me to change this x to y? Like this. Is that still the same? Anybody?
Yes. Yeah, it's the same.
It's the same, right? So actually, when I call this full function, I pass in the x. What it actually does is there's a local variable since the function receives a parameter. So the first line of this function, what it does is the local variable y need to equal to the incoming x. Okay, you're going to receive the value of x and assign it to this local variable y. And then in this entire full function's execution, while you're calling the full function, the internal y will be changed from 5 to 10. But will that actually impact the x, whichever you send in? No. Okay, so the x you send in from the outside remains x. Whatever you did is you pass in the value of x to y. Okay, you're sending in the value. So basically in this line, or in the first line of this full same place, you pass the value of x to internal variable y. Okay, so internal y equal to 5 after this line. And then you change the value of y. Okay, but it will not change x. So at the end, x is still 5. All right, I'm not going to write this in the Java code, but for you guys, if you're not familiar with this, you should practice and test it by yourself. Okay, now for the second question. Let's do this. I have a class called user, and user have a field, age, and a full function. So the first thing here, when I do this, u equals new user. Now question, okay, question. Right after this line, right here, right after this line, when the user just created, what's the age of u right now?
You don't have an age for it, right?
I don't have an age. If I'm doing system.out.println u.age, what will be displayed?
That would be 0. The
0.
default is 0.
Okay, so basically in Java, for any field, by default, if you're not giving a value, by default is 0. Okay, now what about this? Let me ask you in this way. If I have a main function, public static void main, okay, in the main function, I'm defining this int z, and I don't give a value. I'm directly system.out.println z. What will be displayed?
Error.
Yes.
Because you didn't initialize.
Yes. Okay, so z is not a field. Do you remember the difference between field and variable? Yesterday I talked about, right? So z, you can only say this is a variable, but it's not a field. For any local variable, if you want to use it, you have to assign a value. You have to initialize. If you do not initialize it, you cannot use it. This line will give you a problem. Okay, but for the field, since this field is an object level field, whenever you're creating an object of this class, if you're not giving value to this field, then this field will have a value automatically, which is 0. And then if you want to display it, you will have 0 in here. Okay, now once you have 0 in here, by the way, okay, now since we already talked to here, if this is Boolean, by default will be the age. What will be the Boolean value by default?
False.
False. What will be double?
Zero.
Is 0.0. Okay. What will be char or car, whatever you want to call it? It's nothing. Okay. Now what will be this? Let's say user, or let's say a string or hello world. Hello world is my class. What will be this?
No.
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 Okay. Now you can see if it's a boolean, by default is false. If it's int, is 0. Okay. Now, how many different kind of primitive types do we have in Java? Anybody know?
I think
8.
that's 8.
8. Everybody know what are they?
It's char, int, long, double, float, boolean, 1, 2, 3, 4, 5.
Okay.
Can't remember.
Okay. All right. These are the 8 primitive types. Does everyone know how big each one is? When you say how big, you need to have a measurement, right? How do we measure the size of each one?
You use bits.
Bit, right? Now let's talk about 1 bit. What 1 bit can represent? I'm not asking how big it is, okay? 1 bit is already the most basic size. 1 bit, when we talk about 1 bit, we're talking about in the binary, okay? 1 bit can only be either 0 or 1, right? There's only 2 possible values, 0 or 1. So 1 bit is either 0 or 1. Now, how many bit per byte? Anybody know?
8.
8? Yes. 1 byte is 8 bits. Okay. Does anybody know the other things? Like how many bit per int?
32.
32. How many bit per long?
64.
64.
How many bit per double?
64.
Float?
64.
Okay. All right. I'm gonna do this. Okay. I'm gonna rewrite all these. I'm gonna write in this format. Byte, boolean, char or short, char, int, float, long, double. Why am I writing this? The first two, they are only 1 byte, means 8 bit. Okay, the second two, they are both 2 byte. The third two, they are both 4 bytes. And the last two, they're both 8 bytes. Okay, 8 byte is 64 bit. All right, you need to remember this. But there's one thing probably is different, is the boolean. Okay, how long do we actually need for a boolean?
1 bit, right? It's only a binary value.
Yeah, we only need 1 bit. We don't need the entire byte, right? 1 bit, which can only represent 0 or 1, is good enough to represent a boolean. But are we going to say in Java 1 boolean is only 1 bit? No. Java is saying this. Even everything, the most basic is a bit, but in Java, we always say byte is a most basic operating unit. Okay. Otherwise, Java will have a lot of memory spot in there, like fragile pieces in there. He doesn't want to deal with a lot of single bit inside. He just want to make sure everything is byte by byte. So even it's a boolean, use 1 bit, but they say we're going to take 1 byte for the boolean. Okay, but also in some different JVMs, in some special designed scenario, maybe the boolean someplace, the boolean takes 3 bytes, 4 bytes, 2 bytes. Okay, in some special scenario, but most likely in the most scenario, 1 boolean is 1 byte. Okay, 1 byte is also 1 byte. Now short and char, they're both 2 byte. Char in Java, 1 character is 2 byte, means 16 bit. Okay, now all these, beside the Boolean, all these others, they can be considered as number. They can actually convert. Okay, now you can actually see this char c equal to 97, right? If I system.out.println c, what will be displayed?
A, lowercase.
Yes, it will display A, right? Do you know why?
It's the ASCII table.
Yeah, it's the ASCII table. Okay, in the ASCII code, at least you should get familiar with the different basic things: capital A, lowercase a, and number 0 or whatever. Okay, so whoever doesn't familiar with the ASCII code, take a look. Okay, basically these are the Java primitive types. So if I'm defining a byte in here, for example, this is a byte. Now by default, byte is 0. Boolean by default is false. Short, char, int, float, they are all by default is 0. Okay, actually even Boolean by default is also 0. But when you display a Boolean value, 0 represent false. Okay, double is also 0 by default. But there's a dot in between, so when you display, it's going to display 0.0 like this. So they are all 0, just represented in different format. Now, what about, let's say, string s, you don't give a value by default, or the thing we have in here above called hello world, you don't give. Then it's a reference. Yesterday and today we said as a reference, if it's a hello world reference, you will have a reference address in here. If we say hello world equals to, for example, new hello world, then you will create an object and assign the head address to this location. For example, become 1000 or 2000, whatever. But if you're not assigning anything, then by default, this value is also 0. Okay, since it's also 0, so when Java is trying to display this reference, this thing will be displayed as null. Okay, now it's just a representation of a reference where it's pointing to 0. Now the question is, I keep saying a reference, you can have a value of the address, but what is the format of this address? Is this address a short, or this is an int, or this is a double, or this is a long? Anyone know in Java what's the format of this address?
I think it's long, right?
Long? How do you know that?
Because the hash code is kind of long.
Oh, it's a very long number, so it's long. No. Okay. So when you go to Best Buy to buy a computer, you know, all the computer right now is 64-bit computer, right? And if you're using Windows, then the Windows is also 64-bit. But actually, let's say 20 years ago, even at 2020, 2000, year 2000 at the time, your computer probably is 32-bit. Okay. Now, what's mean your computer is 32-bit or 64-bit? What is this talking about? Anybody?
It's talking about like the system's just like the system's minimum. Sorry, I don't remember.
Okay, so there are two different things you need to be clear. Okay, first is your computer is 64-bit. Second is your Windows is also 64-bit. Okay, when we talk about the computer is 64-bit, means what? Means the hardwares you have in your computer, like the memory, your disk, everything. You know, when we search for something on the memory, we need to give a memory address. And those address in the computer, those address in your hard drive, in your mainboard, everything, is a 64-bit number. Okay, originally 32-bit computer means the number is 32-bit. Your computer, the hardware is supporting this long number. Apparently 32-bit is not big enough, so they increased to 64-bit. Okay, now when we come to the Windows, if Windows saying 64-bit means the operating system is able to give a command to your hardware by using a 64-bit location to tell the CPU you go to this 64-bit address to work. Okay, now in the old time, if your computer is 32-bit, can you install a higher version of 64-bit Windows? Can you do this? 64-bit Windows on a 32-bit computer. Is this going to work?
No, because the hardware cannot support it.
Yes, the hardware does not support that long, right? Now, how about this? If you have a fancy 64-bit computer, but you just install a 32-bit Windows on it, will that work?
I guess yes.
That is fine. Okay, technically, maybe there's a lot of issue, but technically it's doable. Okay, so basically you're just waste a lot of your hardware process, but you're just using a low piece of Windows. Okay, so this is 64-bit means. Now come to our Java. Our computer and our Windows is 64-bit. What about our JVM? The answer is your JVM is only 32-bit, even you're using 64-bit computer right now. Okay, so 32-bit, what is 32-bit in here? What number 32-bit?
4 byte.
4 byte. So is this address an int or float? Anybody?
I think it's int
Why?
because it's int can convert to other number.
Okay. Well, the reason is we're talking about the memory address. Do we need a dot in between? Do we want to say the memory address is 2.5? We don't.
No.
Of course, it's an int. We don't need a float number in here. So the address in here is actually an int number. And the int number by default, if you're not giving anything, the int by default is 0. Okay, if you give an address, 2000, 3000, whatever the address, then that will be an int number. Okay, so right now your Java is 32-bit. Okay, just remember this. These are the primitive types. For those non-primitive types, for example, like hello world, now this reference by default will be 0, and 0 when you display it will be null. Okay, these are some extra things I just want to mention in here, just in case. Just in case I just sent it. Okay, now come back to our question in here. So this is an int. By default is 0. Okay, so when I create this user like this age inside is 0, and when I display the user, the age is 0. Now after that, I say u.age equal to 5, and then say. So what this line do? This line basically is setting the age, change the age from 0 to 5. And next line, I'm sending this u to a full function. Why am I calling this way? Because full function is an object level function. So when I call it, I need to call it from an object, u.full, and then pass u itself back to the full function. Okay, and I'm changing the age to 10. So what actually happened is, if I'm drawing a picture, means I'm having a thread trying to do some logic in here, and in the thread is saying first user u equals new user. So right after this line, on the heap, I'm going to create a user object. User, and since we already know, there's a field called int age. At the very beginning, the value is 0 at this time. Okay. Now after you create this object, it has an address. For example, let's say the address is 3000. So this reference user u right now is pointing to 3000. Okay. So I can draw a line between these two. Means this u is currently pointing this object. After that, you say u.age equal to 5. When you say u.age equal to 5, what that means? Means you're trying to assign 5 to u.age. u is 3000. u.age means on the 3000 location, find the age. And you're assigning 5 to this field. So this field changed from 0 to 5. Okay, this is what happens after this line. After that, you call u.foo equal to u. So the foo function is an object level function I can directly put in here. So I can say on this object, I have a foo function. Okay, originally located in here. And then I'm calling u.foo. Basically, you're going to this 3000 location and calling the foo function. And since you're calling the foo function, it's a function, so you're going to create a stack inside. Okay, so you're calling this u.foo. Let's see what happens in this function. The first function, this foo function, saying when you call it, you need to pass me in a user object. User u, but actually I can change this variable to y as well, and what it does is y.age equal to 10. Okay, so for the first line of this function is actually happening is I need to say y equals to the outside parameter you send me in u. So basically in here you're calling u.foo u. Okay, so this u is the object you use to call this function. And the first thing you're going to do in here is to send this u, assign it to y. And when you do this, what happens? What happens is y is a reference, it's a user type reference, y. Originally, it's waiting for something, now send it. You're going to send the address of 3000 to this y reference. So after the first line, this y is also pointing to this location. And then you say y.age change to 10. So basically you come here again, change this from 5 to 10 again. Okay, now after you change it to 10, your function finished. So basically after this line, after the foo function's execution, the y, you use the internal reference to change the age to 10. Okay, did you change u? Well, both u and y still pointing to 3000. Their value 3000, nobody changed it. Okay, so u still pointing to 3000, y still pointing to 3000. But since the function is finished, y disappeared. U still exists. And at the end, you're trying to display system.out.println u.age. U still pointing to 3000. You're just trying to display the age on this location, which currently is 10. Okay, so in both examples, whatever I'm doing is initial the value as 5, send the thing into the function. The function will change it to 10 and then display the value at the end. But for the first question, since the field I'm using here is a primitive type, so the value are directly copied into this internal value. Okay, so y directly got a copy of x, and then you're modifying. So I can say in the first example, we showed that when you call a function, Java is passing by value. Okay, so what is this question originally asked about? This question is Java passing by value or passing by reference? This is the original question. What is this question talking about? This question is talking about when calling a function in Java, is the parameter we're going to send in passed by value or reference? This is the question. Okay, so in the first example, we can see when we're calling this full function, the x outside hasn't changed. It still remains 5 even after the function call. So we just pass in the value of x to this function for calculation. Okay, so Java is passing by value. Now in the second question, we send in this user object. So we can say the user is still the same user, so we actually pass in the reference of the user, which is the location, into this function to execute. So in the old time, people prefer to say this, Java is passing by reference. Okay, so like 10 years ago or 20 years ago, when people ask you this question, is Java passing by reference or passing by value? Your answer should be, if it's a primitive type, for primitive type, Java is passing by value. And for non-primitive type, or for the reference type, Java is passing by reference. Okay. However, recently, in the recent 10 years, people like you to directly answer Java is passing by value only. Why is that? We don't have to explain the top one, but for the bottom one, we are passing in this 3000. Okay, when we call this function, we send in the address of 3000. We copy 3000 to the internal variable y. 3000 is the reference of this object, but is also the value of this user u reference. So we can say Java is passing by the value of the reference. The value is 3000 of the reference u. Okay, so no matter it's a primitive type or is a reference type, Java always pass the value, either pass the value of this primitive type or pass the value of the reference. Okay, so during the interview, if people really ask you this question, no matter you answer in the old way or in the new way, it doesn't matter. Okay, both can give you the credit, but no matter which way you answer, if they need an explanation, you always need to explain in this way. Okay, so basically the two questions I'm writing in here is the correct way to explain this question, and I hope you can understand. Okay, so I'm gonna send you these questions as well on here. Okay, so this is a question. You can use it to explain this question. Any question about this right now? Okay. Next question. Let's talk about immutable and final. But before that, we need to introduce a concept called, let's right click on the src this time. Okay, I'm gonna create a new package called com.mercury.bin. the same level as the basic. Okay, now I'm trying to introduce a concept called Java Bean, or we can call it Pojo Bean, or we can call it Pojo. Okay, so what's mean Pojo? Pojo, short for plain old Java object. Pojo. Okay, so what is that? If you just graduate from school, or when you do the coding in school, for example, I'm gonna create a system. Let's say I'm trying to create a system which the system contains a employee. Okay, so probably I'm gonna define a class called employee. And what do we have in an employee? Maybe it has an int ID, maybe it has a string name, maybe it has some other fields. Okay, maybe the employee can also have some functions. For example, you have public void called login. Okay, every employee, you can log into your system, and then you can log out to your system from your system. Okay, or each employee, you can have a function called work. You can do your work. Okay, so probably if you write your project in school, and if you need a class called employee, most likely you're going to define your class some way like this. Okay, but is this the way the industry do? No, industry will not display or define the employee like this. They will not have these. They will not have these functions in here. Okay, instead they will only have the field and some other necessary things in here, but not those login and logout functions. Why is that? Whatever they're trying to do is, for this kind of class employee, which is trying to describe a type of object, in this class, only data, no logic. Okay? Then people may ask, if I really want the employee to log in, what should I do? Or if I want the employee to work, where should I define the login, logout, and work function? Then probably you can define it in another class. For example, you can call it employee behavior, or let's say service, in a service class. Okay, you can define a function called public void login. You can define a logout as well, and also public void work function. Now the question is, originally I defined the work function on the employee. In here, then whenever I'm creating employee, e1 equals new employee, I can call e1.work. I know e1 is working. Or I'm going to create another employee, e2, and I call e2.work. I know e1 and e2, they are working separately. Okay, when I call e1.work, e1 is working. When I call e2.work, e2 is working. But now you don't want the work function to be defined on employee. You define the work function here. And someday, if you're creating an employee service, and then you call es.work function in here, then who is working? So this time, we can send in a parameter. The work function now is taking a parameter, employee. Okay? If you're calling e1, which means e1 is working. If you're calling es.work e2, then e2 is working. Okay? So basically, in the industry, whatever we want to do is do not define this logic function inside an object, inside a class, whichever takes only the data. Okay? In a class, you want to describe something. There's someone keep joining and quitting? Anyone has some issue? Everybody able to see my screen? Or someone cannot? Okay. If not, I hope you stay, okay? do not keep in and out. All right, so in this way, in the industry, instead of defining this logic in here, we define the function in some other class. So in this kind of class, we normally contains only logic. Okay, so this is the way we define functions. And this class, the employee class, contains only data. We can call it a plain old Java object, a POJO bin. Okay, so there may have some other things you can have in this class. For example, you can have constructors, you can have getter and setters, you can have functions extended from object. Okay, now let's talk about them one by one. First, let's talk about the getter and setters. I'm gonna define an employee in here, new Java class called employee. Let's say in this employee, I have private, let's say this, int ID, string name. Okay, now should I keep them just like this, or should I use public or private in front? Well, I haven't talked about the accessibility, but I believe everyone knows that public means you can use it anywhere. Private means you can only use it within a class. Okay. Now in school, most likely you're going to define all this in public, but in industry we don't. We want to keep it as private. Okay. Why we keep it as private? Because we can use different ways to restrict people to say if I want this ID to be able to be seen by some other place, or if I don't. Okay, now I keep them private by default, then you can have the ability to control it by using the getter and setter. So what is getter and setter? So let's say getter. For each field I can have a getter. Getter function, we can define it like this: public int get ID, return ID. By calling this function, you can return the ID field. Okay, both ID field and the getter function, they are object level function. So they're in the same level, and when you call this function, you can return the ID on the same object. Okay, so this is the getter. Now what is the setter? Setter looks like this: public void set ID, which take an int type ID. Why I'm taking an int? Because the ID in here is int, and then I'm going to say this .id equal to ID. Okay, now here's the question: what's mean this? Anybody?
It just refers to the field name.
Just this itself, it referred to the field?
Instance object.
No. This means the object where this function is coming from. Okay, look at this function. This function does not have static in front. This is an object level function. Object level function, as we said yesterday, it only can be called from an object. And that object, wherever this function is coming from, that object is this. Okay, so someday, if, for example, I should not have the main function in here, okay, but I just give an example. When I say employee E1 equals new employee, and I say employee E2 also equal to employee, and when I call E1 dot set ID 1 and E2 dot set ID 2, when they call the set ID function, each set ID has a this. Are these two this the same? No. Okay. When you call E1 dot set ID, when this function is being executed, this inside set ID represent E1. All right. So when you call E2.setID, this keyword in the set ID represent E2. So basically is you have a thread, and in the thread you're calling E1 equals new E2 equals new E, and then you call E1.setID1, E2.setID2. What happened is you're creating two different E objects. Both are employee type. Okay, and each one have a field called int ID inside this also, and each one also have a function called setID. Okay, this one also have it. Now E1 is pointing to this, E2 is pointing to this. And when you call E1.setID and E2.setID, so E1.setID is saying this dot ID equals to 1, because you're saying this dot ID equal to ID. You pass in 1, so it's basically this dot ID equal to 1. And this one is saying this dot ID equals to 2. Now what is this? Since you're calling E1.setID, so this represents E1, means E1.ID equal to 1. And you're calling E2.setID, so this represents E2. And ID in here equals to 2. Okay, so this represents the object wherever this function is coming from. Okay, so this is current object where the function is coming or defined from or calling from. This. Okay, so this we call it setter and getter. Okay, so by using the setter function, I can pass in a value of an ID, and I can modify ID. By calling the getter, I can also get an ID field, and both functions normally are public. Okay, or now people may have question: if we have both getter and setters, why can't I directly change it to public? Why do I have to private the field and give a getter and setter? If I directly public it, I can directly modify the field. Isn't that good? Anybody knows?
I think the answer is no. We should not directly change the property of an object.
Why is that? That's the question.
The question is maybe we change it to some way that we don't want to.
Maybe you can pass it like not an int and break the system.
Oh, but the same thing in here. Even if you're having getter and setter, you can also pass in something which is not an int, and that will give you exceptions. Actually, when you call the function, when you write in the code, no matter you're doing public in here or you're sending in here, it'll always give you exceptions.
Okay.
Okay. The reason is actually a very easy reason. The reason is first, you don't want people to see what field do you have. Okay, you want to keep some privacy about your system. Maybe some of the field you don't want to give getter and setters. Okay, and the second reason is maybe sometime I can change. For example, I can remove the setter from here. Okay, for this class, I only have getter, no setter. But if I change this to public, then there's no way I can restrict people from setting the value to it. Okay, or sometime we don't want people to have the getter. We don't want people to see the value, but I can set it only. Okay, or I can say I'm gonna change it to protected, or change it to private. I can change the visibility of the setter and getter. Okay, but most of the time it should be public. So basically, by using the getter and setter, you have more flexibility. Okay, or in some extreme condition, maybe this field you define is very, very long, has a very long name, but I don't want to use the very long name. I can easily change the function name called getID and setID. Okay, all right, now let me ask you this question. If I change the function to foo, is this still a getter function?
Yes.
Yes.
It functions the same, right? But remember, this is no longer a getter. Okay. Now how about this? If I do this, is this a getter? Let's say you're an int, but I'm actually returning you a string. Okay, I'm gonna return you integer dot toString ID. Okay. If your ID is number 1, int 1, I'm going to return you a string 1. Is this getter? No, it's not. Okay, it's not. You should not return different format. Now, how about this? You ask me to return ID, I return ID plus 1. Of course, this is not a getter. Okay. Or how about this? You ask me to return ID. Yes, I'm going to return you ID, but before that, I'm going to sys out ID is ID times 2. Okay, your ID is 1, but I just display ID is 2, and I actually give you 1 back. Okay, you still get the ID, but I just display your ID is a round number. Is this getter? Well, actually, this doesn't impact, but you should not do this, okay? Because this is a Pojo, this is a Java Bean. You should not do some weird logic inside, okay? And I'm not going to find any other example. What I'm trying to say is a getter and setter then is supposed to call this name and supposed to do these things only, okay? Do not do any weird thing inside. Why is that? Because a lot of frameworks like Hibernate, Spring, all these other frameworks in the future we're going to learn, or something that you will learn or you're going to use in the future work. All those frameworks, they probably will ask you what's your field name. Okay? By doing that, they will automatically search your class to find if there's a function called getID, if there's a function called setID. If you name your function like foo, even you're telling him my field is called ID, he could not find the foo function. Okay, he doesn't know there's a foo function. So this setter and getter is like a naming convention, how we define the functions. We always define in this way, so the frameworks also assume we're defining this way. Okay, and they also assume the return type is supposed to be the same type as the field type we define in here. Okay, so don't do any weird things. These are getter and setters. Okay, as a Java bean, beside the getter and setter, we can also have constructors and the functions extended from the object. What are these?
Okay, big question.
Yes.
On a setter, do we usually write a logic in a setting in a setter method?
Say it again.
Do we often write logic in a setting method, in a setter method?
No, no matter in setter or getter, we don't write additional logic, just like this.
Okay.
Okay. So this ID represents the ID of this object, and this ID is the sending ID. Only easily set it inside. Do not do any additional logic. Okay, both setter and getter. I was just using getter as an example, but actually setter is the same. Okay, so there's only one thing I want to mention. If the field is a boolean, for example, called done, okay, then the getter and setter for this boolean field is different. For the setter, still called set done, okay, return a boolean. There's nothing different. But for the getter, for a boolean field, is not going to call public boolean get done. You're not going to call this. Okay, you're going to call is done. This is the only different. Only for boolean. Okay, for any boolean, you're going to use is. All right, this is setter and getter. Okay, for a POJO bin, beside the getter and setter, we can also have constructor and other functions. And let's have a break. Come back, continue to talk about the constructor and functions. Right now is 3:43, and we're gonna come back like in 20 minutes. Let's say 4 o'clock. Okay, 4 o'clock. 17 minutes.